So let's take a quick look at what a logarithmic function is. These are commonly called logs, and they are used primarily to scale some really large or really small numbers. And it's an inverse function of exponents, and we'll look more at that in a moment. You may have heard of the pH scale or the Richter scale, and these are examples of logarithmic functions. So just in case you've heard of pH, you'll get that in Chemistry 12, or if you don't take chemistry, you might hear about it. But it talks about how strong an acid is, and so a lot of common things around the house they'll talk about that it's pH balanced or pH safe. Maybe the Richter scale. Richter scale is used in geology, but it talks about earthquakes. So if you heard of an earthquake that was a magnitude 4, and then you heard of an earthquake that was magnitude 5, and you might think that there's not much difference between those. But the magnitude 5 is actually 10 times worse than the magnitude 4 earthquake. So here's some really big numbers. The first number I see there is a million, one with 6 zeros. And with the 6 zeros here, what we have is there we go, the 6 zeros, and that has a log value of 6. Wow, this looks like a billion to me, and this is getting to be some really big numbers. Well, we can just say 9. I don't know what this number is here, but there's a whole lot of zeros here. The log of that number is simply 18. So once again, it's easier to say 18 than it is to say 1, 0, 0, 0, etc. Okay. Similarly, with small numbers, here we have 0.001. Well, we would just call that a -3 and a -6. Look at this giant number here. It's just easier to call that -18. And in my next video, I'll show how that all works. But what I want to make sure you understand is what I mean by an inverse function. So here we have some kind of variable a, and we're adding 5. And if you were doing some algebra, how would you solve for a? Well, the technique that most math teachers would teach in algebra is you do the opposite of adding. You subtract. So if you had 8 take away 5, you would find out that a equals 3. And so adding and subtracting are inverse functions. Adding and subtracting are inverse functions of each other. Okay, what about here? We've got another question. B times 5 equals 15. Well, once again, we would look at that times and we say, okay, how do I get rid of this? Well, I'm going to divide by 5. Okay, so I'm going to divide by 5. Once again, what am I doing? Well, if the question has multiplying, I use division to solve it. And this is the whole secret of algebra. Well, here I have a power. I have, I do have an exponent, but I know the exponent. It's the base that's unknown, okay? And we know that c cubed is 125. So what do? Well, we use the opposite of powers. We use roots, okay? So what we do here is we would take the cube root of this, and we would take the cube root of that, and we would find that c is 5. Okay? But you'll notice in the last example, what we have is that we don't know the exponent, and that's how these two are different. You notice in that question, we knew the exponent, and on the bottom question, we don't. So there's the difference. One, we know the exponent, and the other, we know the base. When you are trying to find the exponent, you do the opposite feature. The opposite function is a logarithmic function. So to solve this, you would say the log of this, okay? And you would find that the log of 125 base 5, you would find that D is 3. All right, so just a quick brief summary of what I mean by inverse function and what a logarithmic is. Next video is going to get into how to use those with common logarithms.